Okay, so the steps for optimization was that we were determining the primary equation, then we were determining the constraints, then we were plugging the constraints into the primary equation, taking the derivative of that primary and setting it equal to 0, and then solving and including whatever units were applicable for that question. Okay, so the one that we left off on last class had to do with a cylindrical soda can. So we have, what is the radius of a cylindrical soda can with volume of 512 cubic inches that will use the minimum material? So again, our primary equation is the thing that we are trying to minimize, in this case, the material, which is like code for surface area, right? The amount of aluminum that we're using on this. So we came up with the equation for our surface area. Area equals 2 pi r squared. That was the top of the can and the bottom of the can, right? We have circles on both. And then what we said is if we were to like slice that can and unfold it, we would get a rectangle. And the length up here would be the circumference of that circle, 2 pi r. And then the height would just be the height of the can. And so we could add those things together and that will give us our total surface area. So that's the thing we're trying to minimize. We also need to determine our constraint. And so our constraint is any additional information we have in this problem. And so our constraint here said that we are limited by having a volume of 512 cubic inches. We talked about how to find that volume, area of the base times the height, and then the base was a circle. So when we did area of the base, pi r squared times h, that gave us our constraint, and our constraint was limited to 512. Okay, Riley, we're gonna start with you. What would I do from here?
You could solve for h using the constraint, and then therefore you would get 5/12 over pi r squared. You plug that in for the h.
Hold on one second. Let me write it down. So I agree with you. We're going to isolate a variable in our constraint. That means h is equal to 512 over pi r squared. We are not isolating the r squared because we can't really isolate the r because there'd be a plus or minus and it changes the equations. And so then you said we're going to do what with this, Riley?
We're going to plug that h equals constraint into the primary of h.
Perfect. And so that would give us area equals, first term stay the same, 2 pi r squared, plus then this would become 2 pi r times what?
512 over pi r squared.
Perfect. What can you do with this?
You could multiply it out.
What do you mean?
So you could have 2 over, or I think it would be 124 over r.
1024 over r. Okay, so what you're saying is that we had this 2 times this 512, and that gives us 1024. The pi's cancel out, and then one of these r's cancel out, so you're still left with 1 r in your denominator. And then we get area is equal to 2 pi r squared plus 1024 over r. So this is still our area equation, right? We have determined our primary, determined our constraint, isolated a variable in our constraint, plugged that into our primary equation, and then we simplified. And we might even do one step further to simplify to make the derivative of this, which is what we want, a little bit easier. And so that step might be to rewrite this as a full power function. So 2 pi r squared is already a power function. We are going to change this to 1024 r to the negative 1. It's going to just be easier to take a derivative if you're working with a power function, write it in power form. Okay, now this is just area. So I don't want to set this to 0. I don't want the area to be 0, then I don't have a can at all. What I want is I want to find the minimum area. And so that's why we take a derivative and then set that equal to 0. Let's go back to Kleiner because I think that's where we left off and we were at a similar place here yesterday. Kleiner, what would we do now?
So now we'd find the derivative, which would be 4 pi r minus 1024 over r squared. I just did that step in my head, but
okay, that's fine. And then over r squared. So again, I'll show that as 2 steps real quick. We're finding a prime, so make sure it's labeled as such that it's not just a random floating equation. And then you have 4 pi r minus 1024 r to the negative 2. And I agree with Kleiner, it's probably going to be easier to write that instead of times r to the negative 2 as divided by r squared. And from here, what would you do?
Okay, from here, so I set equal to 0 first.
Okay.
And then I multiplied everything by r squared. to get rid of the fraction.
So you can do that. There's another way you can get rid of the fraction. There's something else you could do that's maybe easier than like multiplying everything.
Oh, I
Any
think I know.
ideas? Go ahead, Kleiner.
So would you put 1024 over r squared on the other side to make it positive, and then you can just cross multiply?
Exactly right. So that's just going to make your life a little easier. We're going to get to some complex problems with like square roots and stuff. It's just going to be harder to do that multiplication and get a common fraction and then get rid of it. It's easier just to get rid of it by adding it to the other side, multiplying it up. Okay, so this gives us 1024 is equal to, did I do that right? Yeah, right. Am I supposed to have a pi? No, okay. 4 pi r cubed. There we go. Okay, and then what, Kleiner, from here?
So from here you can divide by 4 pi, divide 1024 by 4 pi.
Good, and then we're gonna have r cubed, so then we're gonna do what final step?
Cube root, the whole thing.
Perfect, so we'll take the cube root, and we get this answer, right? So we get r is equal to the cube root of 1024 over 4 pi. Now, we talked about this a little bit last time. A couple things. One, we got to make sure we're answering the question being asked. So sometimes the question is find the rate, find the area, or find the height, or find the volume, right? I could ask any of those questions here. You now have enough information. You might need to keep solving a little bit further, but you have enough information. You've done enough work in order to be able to go through the process of answering that. On this question, it just wanted to know what is the radius. So it wasn't asking us to find some area or volume or something else. So a lot of times in the previous problems, we had to go back and plug this into our constraint. On this one, we don't have to. It's not asking us for any additional information. 1024 divided by 4 does simplify. I think it's like 256 or something around there. Doesn't matter. Right. Yeah, so you can totally simplify it if you want. If this was no calculator, we did the rest of this no calculator pretty easily, right? So again, if it was no calculator, they don't require that you simplify that. You can leave it as 1024 over 4 pi. It's not that hard of a simplification, but if you simplified it wrong and got like 257 or 254, then your answer is wrong and this one would have been right, okay? With one exception. So we're missing something on this answer. Kleiner, what am I missing?
Inches.
We are missing the units. So make sure your units are included and make sense, right? So a radius is just inches. It's not an inches squared or an inches cubed. I know we had cubic inches to start, but that was a volume. If we're just dealing with the radius, our radius is going to be in inches. And you're welcome to abbreviate, but you have to abbreviate correctly, IN period. Okay. And again, it would have been totally fine if you simplified this down to 256 over pi inches. If it was a calculator section, then you, yes, would have to simplify it using a calculator and give a decimal. But generally this would be no calculator and you could stop at that step. Any questions on this problem? Any questions? Ask them now. Next one gets really fun. Is everybody ready? Okay, that was a good warm up. Okay, this one looks like it's going to be easy. It's a very short question. That tends to be the harder stuff because then you have to figure out way more information. So this question says, find the area of the largest rectangle that can be inscribed in a semicircle of radius 4. So find the area of the largest rectangle that can be inscribed in a semicircle of radius 4. I've seen this question several times on AP exams. You're going to see it, I think, in your Princeton Review and in Quest also. Any guesses on what I might be able to do to start here? This is a hard one. Any guesses?
Would you start out by drawing a diagram?
I would draw a picture. Yep, I would draw a diagram. Okay, so Jack had that exactly right. I draw a picture. Like the situation is that I have a semicircle. So half of a circle is a semicircle. And inside of that semicircle, I have a rectangle. It's inscribed inside. So it's important that you read that correctly, that you know which goes inside which. The rectangle goes inside of the semicircle. Okay, so here's where the problem gets hard, right? If I were to ask you to write an equation of a rectangle, you might write, because that's the thing that we are trying to find, the area of the largest rectangle, you might write for the rectangle, area equals base times height, right? Or maybe even x times y, something like that. That's what you would probably write for your rectangle. And then if I asked you to come up with an equation for a semicircle, an equation of a semicircle, most guys would also choose area. They would choose like 1/2 pi r squared. Both of these are wrong, so you don't need to be writing these down. You should just be paying attention because both of these are not helpful, and I want to explain why. Okay, like yes, that is the area of a semicircle, and I would have a radius of 4, right, which isn't changing, but that would just, if I plugged that in, that would just give me what the area of that semicircle is, which is not a thing I can then plug in because the area of the semicircle is not equal to the area of the rectangle. So those A's are different A's. Also, I can't really isolate a variable in my constraint to plug it into my primary, right? If we're saying that area equals x times y, the area of the rectangle is the primary, all I have to work with over on the other equation is an r. And r doesn't go into x or y, right? R would be this length, x would be this length, y would be this length. Like none of that corresponds, which is why this becomes a hard problem. Okay. All right. So I'm going to walk you through how to start this one, because even just starting this one, like this is where most guys are like, I literally have no idea what to write down at all. And it is a little bit complicated. Okay. Make sure you're paying attention here because there's an aspect of this that's going to show up kind of throughout other sections of the AP exam. And it just has to do with equations of circles that you need to know how to do. So really quickly as review. If I were to ask you the equation of a circle, so not the equation for the area of a circle, but the actual equation of a circle, right? If this is x and y. So this kind of goes back to algebra and geometry and pre-calc and all that kind of stuff. The equation of a circle, does anyone happen to know?
Is it x squared?
X squared plus y squared equals r squared.
Perfect. And that's an equation of a circle centered at the origin is what I should have said. So an equation centered at the origin, equation of a circle centered at the origin, x squared plus y squared equals r squared. Okay, well, we know our radius is 4. So we could adjust one thing in this equation, which would be x squared plus y squared equals 4 squared, or x squared plus y squared equals 16. Okay, in general, that's true. Like that would be the equation of a full circle on an x and a y grid. Now, what we have is we have a half of a circle. So we're going to draw our circle like this. So we're not going to include that bottom portion. We're just going to include this blue portion. And so the mistake I see from a lot of guys is that they'll just take this equation and divide it in half. They'll think that that is how you would accomplish the semicircle, is by dividing this equation in half, which is not correct. Okay, I don't want to divide all this in half. That's not actually going to do anything to this circle. What I'm really getting rid of is I'm really getting rid of all of the negative y values. And I'm changing it so it's now a function, right? So I can now pass the vertical line test. I guess technically we don't have like this portion. It doesn't really cut here. But all that exists is that top half of the circle, right? So I don't have the bottom half anymore. I don't have the yellow dotted line. I just have the blue portion of the circle. And so now that it's a function, now I can isolate the y. And to isolate y, I would get y squared equals 16 minus x squared. You should write this down, all of this part. Now, when I take a square root, we've said, like, if I'm the one that takes the square root, we get a plus or a minus here. So I would get like plus or a minus square root of 16 minus x squared. But because it's only the positive y values, everything up here is positive y, I don't need the minus sign. The minus sign would be the inclusion of the yellow dotted part. So I don't need the plus and the minus, it's just the plus. So the equation of a semicircle with a radius of 4 centered at the origin would be this. It would be square root of 16 minus x squared. That is the equation of a semicircle. Okay, centered at the origin. So the key here was to really put that semicircle on a grid, like to put it on a coordinate plane, so that now we have, and I'll make that semicircle blue just like it was in the previous one. Now we have the equation of our constraint, right? The thing we're limited by, which is y is equal to the square root of 16 minus x squared. That's the equation of the semicircle. I'm not trying to get the biggest semicircle or the smallest semicircle. I'm trying to get the biggest rectangle. Okay, are there any questions so far? This is where this gets a little, like many students might already be confused. Do you have any questions? Because if you have one, maybe another student does too.
Can you explain why you're solving for y? I didn't quite get it.
So we just wanted to come up with an equation. If we left it as x squareds and y squareds, there would actually be a full circle. Okay. And so I don't want a full circle. This equation is for the full enchilada, the full circle. I don't want that. I want the semicircle. So I just want half of it. Okay. So what I have to get rid of is all the negative y values. And so the way to get rid of those negative y values is to isolate y and get rid of the plus and the minus, to get rid of specifically the minus portion. Okay. So that's why we isolated y, so that we could restrict our range. We just want the range of the half of it. Okay. You could have isolated x. That would have been fine too, but it wouldn't be a function, right? So if I isolated x, I would just have like positive x. Sorry, I'm mirroring you. Positive x, it would be over here. So it's going to be easiest to solve this if we're actually using a function. Okay, does that sort of make sense? Ish, a little bit, maybe, yes, no? Okay, we're going to move on. So now we have our rectangle. Here's where this is still hard. So hopefully you haven't like taken off without me trying to solve this because you're probably making a mistake. That's really common here. So this is my rectangle. Again, we're on a coordinate plane. This is x, this is y. Common mistake I see is that students now identify the primaries, what we had before, which is area equals x times y, which is actually wrong. There's a reason why, and we'll get to it in a second. At least now I have x's and y's in both equations, right? So at least now, instead of having 1/2 pi r squared or some equation like that, I now have my radius input in my constraint, and I have the equation of the semicircle input in my constraint. And the variables I'm using in my constraint match the variables I'm using in my primary, which is what I want so that I can isolate, substitute in, and then get rid of a variable. Okay. Does anyone have any idea why that primary equation is a little bit wrong? It's close, but it's wrong. If you think you know, just unmute.
Is it because, oh, Josh, go.
Okay, so what I was thinking is that x only accounts for the positive side, but
correct. And Riley's shaking his head too. You guys are both going to say the same thing. So yeah, x, when we're talking about x, that's the distance from here to this point. That would be an x, right? And so that portion is not the rectangle I want. I don't just want x times y. I need that whole rectangle. So Kleiner, what would you change about this equation, do you think?
I would just say 2xy.
Perfect. And that's exactly right. So the base is actually 2x, right? Because that rectangle centered at the origin, x is only going to be the distance from the origin out. And so I want the entire distance. So I want 2x. So that's going to be my primary equation. Okay, now we have our primary equation, area equals 2xy. We have our constraint, y equals the square root, just the positive version, of square root of 16 minus x squared. Okay, we've already got a variable isolated in our constraint. That makes this easier. I can take that and plug it into my primary. This is still a hard problem from here. It was a hard setup and it's still a hard problem because now I'm going to have 2x, a function, times another function. That's a hint. Okay, I'm going to need the derivative, and I have two functions times each other. And in one of those functions, I have the square root of another function, okay, inside of it. So we are going to cross our fingers and we are going to try some breakout rooms. And I want you to work on this. I'm going to give you a good amount of time, probably 5 to 10 minutes to work on this, okay? With your partners, everybody unmute when you get there, talk through what to do next. Hopefully all of you have at least this portion written down. Fingers crossed these breakout rooms work today. Go ahead and join when it shows up. Okay. All right. Okay. So what'd you do from here?
Well, I plugged in y into the primary equation. So
Perfect.
A
So we plugged
equals,
our constraint into our primary. We get A equals
2x times square root of 16 minus x squared.
perfect. And then you're exactly right. We need product rule since I have multiplication and I want to take a derivative. So we're going to have A prime, B prime. What was your A, Evan?
2x,
Okay. What's your B?
2.
Oh, sorry. That's A prime. Okay.
Oh,
2.
yeah,
Good.
sorry.
That's fine. Okay. And then what's your B?
Square root of 16 minus x squared.
And that's exactly right. I'm going to write that as a power function just to make our lives a little bit easier. So 16 minus x squared to the 1/2. What is B prime?
Okay, I got 1/2 times 16 minus x squared to the negative 1/2, and then times negative 2x.
Fantastic. Evan, there is something that a bunch of students are going to miss on this, and they're going to have done everything else pretty correctly. Please, everybody look up here right now. Make sure you have this negative. A lot of students accidentally multiply by 2x and not negative 2x, and it changes all of their stuff from there. So make sure you have a times negative 2x, because again, we're doing the derivative of the inside function. The derivative of 16 is 0, so that goes away. The derivative of minus x squared is minus 2x. Okay, so our product rule from here, before we actually multiply this, I think it's helpful to simplify some things. So in B prime, we can simplify. I have a 2 and a 2. So I have a times 2 and a divide by 2. Okay, so I can cancel those out. Then I can rewrite my B prime as B prime is equal to, I'm still going to have a negative and an x up top. And I'm going to rewrite this without powers anymore. With square roots, it's going to be easier to actually solve this. Doesn't matter what step you do this in. Okay, so now I'm going to have that as my B prime. Okay, let's go to Lewis. Lewis, if I'm actually multiplying through, my A prime would then equal what?
I did 2 times and then the square root of 16 minus x squared,
Okay,
and then plus 2x times and negative x over square root of 16 minus x squared.
I agree with that. Do you want to just simplify that right here? So 2x times negative x is what?
It's just negative 2x squared.
Negative 2x. Oh yeah,
Squared.
negative 2x squared. Sorry. I was thinking something else. Sorry. Over the square root of 16 minus x squared. Okay, 2x times negative x, negative 2x squared over square root of 16 minus x squared. Okay, let's go to Spencer. From here, what would you do?
From here, can you just set it equal to 0?
Yep, so now we can set it equal to 0. I have 0 equals 2 rad 16 minus x squared minus 2x squared over square root of 16 minus x squared. What would you do next?
And then you can add the 2x squared over radical 16 minus x squared to both sides.
Perfect. So when Kleiner was doing that problem before, this is kind of what I was referencing, that there's easier problems if you just add it to the other side versus like try to get a common denominator. It just makes it more complicated. Mathematically, it's the same. This is just a slightly easier approach in my opinion. Okay, let's go to Charlie. What'd you do from here?
This is as far as I got. So do you want to just multiply the root 16 minus x squared on both sides?
Yep, perfect, right? This is like cross multiplication. I can just cross multiply. I've got to technically divide by 1 on the right side. So yeah, I can bring that square root of 16 minus x squared up to the other side. That's going to give me, I'm going to write in white here just so everyone follows along. 2x squared is equal to, what would you have on the right side of this now, Charlie?
I think you would just have 2 times 16 minus x squared.
Correct, because the square roots are going to cancel out. You just need a parentheses there. But yeah, 2 times the square root of 16 minus, sorry, excuse me, 2 times parentheses 16 minus x squared. Because yes, I have a square root times a square root, those cancel out. Okay, from here, what would you do?
Divide by 2.
That'll work. We can divide both sides by 2. X squared equals 16 minus x squared. From here?
Add x squared to the left side.
And what would that give you?
2x squared is equal to 16.
Okay, keep going.
Divide by 2 on both sides. You get x squared is equal to 8. And
Okay.
x is equal to the square root of 8.
Perfect. Now, a lot of you know square root of 8 is equal to 2 rad 2. It's not actually very helpful to simplify it to 2 rad 2 here. Just leave it as square root of 8, and I'll show you why. But we're immediately going to do something and square it. And so it is easier just to square a square root than it is a number in a square root. So no need to oversimplify here. We get x is equal to square root of 8. Now, technically, we took a square root, right? So it was x squared equals 8. What I've said many times is if we are the ones that are taking the square root, then that means we should get a plus or a minus. Charlie, why does only the plus version of x make sense in the context of the problem?
Because you can't have negative distance.
Yeah, so even though I could have like a negative x value in an ordered pair or on a coordinate plane, what we're calling x is we're calling x the length, right? X is a length of a side. And so our length, it wouldn't make sense to have that length be a negative value. So yes, it should just be the positive value here. X is equal to square root of 8. Okay, that's not our final answer. We got to actually answer the question. Jackson Scrimshire, what are we trying to find and what else do we need to do to get there?
We're trying to find the area, so you need to find y. So you would just use that x and plug it back into the constraint.
Correct. So we need to find our y because our area has 2xy. So we need to plug in x equals square root of 8 back into our constraint. We get y equals the square root of 16 minus square root of 8 squared, which is equal to what, Jackson?
Y equals square root of 8 as well.
Y equals also the square root of 8. So we get y equals the square root of 8, x equals the square root of 8. What's your final step that you would do, Jackson?
2 times the square root of 8 squared, which is equal to 16. And that is your area.
Good. Any units on this?
There were no units given in the problem, so just leave it as it is.
So just leave it as it is. Please don't write units squared. The most irritating thing I get sometimes from students. If there's no units, then no units would be a part of your answer. Your final answer would just be 16. One thing Jackson didn't say that I included, we need A equals. So if you just randomly have floating work of 2 times rad 8 times rad 8, that's incorrect. I'm sure he thought that was implied because I said, what is the area? So make sure you have A equals. Make sure you always have your setup there. Okay, any questions on this one? Again, this problem is not overly complicated to actually solve. Like once you get past the derivative, like the rest of the math is not overly complicated, but the really hard part is the setup here, because it's common for us to have no idea what our equation is for our primary and our constraint on a problem that looks like this. Okay, you are going to see these problems again. Make sure you're very comfortable with this setup and why this worked. There's one like this on your quest, so this should help you now also to work through that problem. You'll get some more practice on it. And it's really important you know what we talked about here, which is how to come up with this equation for a semicircle. Like there's plenty of times in an AP question where they'll just give you y equals the square root of 9 minus x squared. What would that look like if I just randomly gave you the equation square root of 9 minus x squared, Kevin? What would that look like?
That's a half circle with,
Yeah.
wait, no, Wait, yeah, that'd be a half circle with a radius of 3.
Perfect, that's it. So it's important you know that, right? So this value is r squared. That's where it's showing up here. So equation of a semicircle is always square root of r squared minus x squared. This is equation of any semicircle. That is an important thing that you know how to find. Or if given a semicircle, you know how to draw it. Okay. All right, we've got one more question. This one is simpler in some ways and more challenging in others. This question says, at what point on the graph of f of x equals -1/2 x to the 4th plus 3x squared plus 5x minus 5 halves? Please write that down. So it wants to know, at what point on that graph does the tangent line have the maximum slope? Maximum slope. I would also write down those two words, maximum slope. This one's easier in some ways because it's not really a huge word problem. I don't have some scenario, a soda can or anything like that. I don't have like other information. So I really just have this one equation I'm working with, and I'm going to try to figure out what I want a derivative of from there. But I don't have like a constraint or something else limiting me in this problem. Okay, this is still optimization because you are still finding a max or a min of something. That's always optimization. Just a lot of the optimization problems we're going to see are more challenging. Okay, pause your brain really quick. Let's go back to a totally different thought. If I wanted to find the maximum area, I would need to take the derivative of area. Everybody is okay with that, right? If I want to find the maximum area, I need the derivative of area. We did other problems where we wanted to find the maximum volume. So what I would do is take the derivative of volume. That's how we find a maximum. If I want to find the maximum of something, I have to find the derivative of that something, and then I set that equal to 0. This is why this problem is tricky, because most people will find the derivative of f of x and then set that equal to 0, because often that's how we find maxes and mins. We just take a derivative and set it equal to 0. That will not work in this situation. Does someone know why? It won't work just to take the derivative of f of x and set it equal to 0.
Would it be because the derivative of f of x is the slope?
Correct. The derivative of f of x is slope. That is the slope equation. So I don't want to know where the slope is 0, which would be what happened if you set the derivative of f equal to 0. I want the maximum slope. So again, if I wanted the maximum area, we take the derivative of area, set it equal to 0. If I want the maximum volume, we take the derivative of volume and set it equal to 0. What will I have to do to get the maximum slope? Let's go to Tanner. How would I find the maximum slope?
So wouldn't we want to find the derivative of slope then?
Correct, which in this case would be f what?
Double prime of x?
Correct. So we would be finding f double prime of x and setting that equal to 0. Okay. If I asked for the maximum value or the maximum output, that's why we would set the first derivative equal to 0. If I just wanted to know what the highest point was, right, that would be the maximum output, the maximum f value, which is why f prime would equal 0. We don't care about that. We want the maximum slope. So we need the slope's derivative, f double prime, to be equal to 0, right? F prime is slope, so the slope's derivative is f double prime. Okay, I am going to give you a minute by yourself. No small groups on this one. Okay, I want you to start working through this problem. Go. About another 30 seconds just to get as far as you can, and then I'll call on someone. Excuse me. Let's go to Nikhil. Nikhil, talk me through your process here. What'd you do?
I first took the derivative of the f of x. So I did f prime of x is equivalent to negative 2x cubed plus 6x plus 5.
Excellent. Keep going.
And then I took the double derivative. So f double prime of x equals negative 6x squared plus 6.
Fantastic. And I'm going to stop you there. Nikhil did a great job because he clarified he's got f prime of x equals and f double prime of x equals. In grading, I'm not done grading your guys' quizzes from Monday yet, but in looking through them, a lot of you are struggling with like labeling and just showing work. Like you have the right polynomial equations or whatever, but you don't have the right like labeling or setup. So make sure you're always labeling stuff. Okay, from here, obviously we're going to set this equal to 0. But a lot of you go about this in kind of a strange way that's not super helpful. So please look up here, even if you already have what you think is the right answer. I want to make sure you can translate this to a bunch of other kinds of problems. Several of you struggled with this again on the test that we just had, or the quiz on Monday. So what I would do from here is I would factor out this negative 6. And I would end up getting an x squared minus 1, which we know we can factor into difference of squares, x minus 1, x plus 1. And again, this equation, I'm setting it equal to 0, but it's the same as finding where f double prime of x has this graph, right? This is the graph of f double prime of x. I've just reorganized it a little bit by factoring out a negative 6. This is a polynomial, or I'm sorry, this is a quadratic equation, and it has 2 zeros, one over here at -1 and one over here at 1. And it's important that we see that our leading coefficient is negative. That means the right side of this graph is going down, or it's simple parabola, it's open down, right? So I know I have an open down shape. If you are avoiding graphing, get over it. Draw this graph. It's going to be helpful for you to visualize these things and understand how they correspond. And it's actually a big portion of the test. You have to be able to understand the graphs. So don't get too addicted to those number lines. Don't use them. I've told you that before. Okay. From here, this is the graph of f double prime, but what's helpful to know about this graph is it's really the graph of the slope derivative, or like slope prime, right? This is our slope prime graph. So this is the graph of the derivative of slope. If I'm looking at the graph of the derivative of something and I'm trying to find a maximum, what am I looking for on that graph? Let's go to Christian. What am I looking for on this graph, Christian?
When the slope goes from...
Not the slope.
Oh, when the
value of this graph changes from what to what?
Positive to negative?
Correct. So I'm not talking about the slope of this graph. This graph is the slope prime thing. I'm looking for where the value of this graph goes from positive to negative, which happens over here at +1. That would indicate a maximum, meaning a maximum on the slope graph, right? So a maximum slope. That's where a maximum would happen. Over here at -1, it changes from negative to positive. So that would indicate a minimum. So that's where we would have our minimum slope, which is not what I'm looking for. So now that we know our maximum slope happens at x equals 1, that does not answer our full question. The question was, at what point on the graph? So this is also where some of you struggled. Some of you just did this in your head or made little like notes up above and wrote stuff like this and don't have anything labeled. You're getting marked off for this. You have to label stuff and show all of your work. So we know x is equal to 1 is where the max happens. We now need to find f of 1, which is -1/2 times 1 to the 4th plus 3 times 1 squared plus 5 times 1 minus 5/2. Yes, it's annoying. Yes, you need to do it. I want you to get 5s. I want to make sure you have all your work shown. Make sure you're always labeling. This simplifies quite a bit. -1/2 plus 3 plus 5 minus 5/2. 3 plus 5 is 8. minus 1/2 minus 5 halves is minus 6 halves or minus 3, which is equal to 5. You need to actually show the work of finding that, and it must be labeled as whatever it is you're finding, f of 1 in this case. Okay, so our final answer is the coordinate 1, 5. Now, the other thing this question could have asked is it could have said, what is the maximum slope? How would you find what is the maximum slope had that been the question? Let's go to Jackson Bernreuter. What would you do to find what is the maximum slope?
I'm not sure.
Okay, so we know that the maximum slope happens at x equals 1. Right? We know that's where the maximum slope happens. If I wanted to know what is that value, what is the maximum slope?
Oh, would it just be 5?
Why would it be 5?
That's the value. That's the y value of the. Oh no, sorry. That's the original.
Output on the original equation.
Sorry,
right?
the y value of the derivatives of the slope.
Correct. Yes, exactly. So what you're saying is we need like the output value of our slope equation, if that was the question, which would mean I would plug this into our first derivative, right? Our first derivative is our slope equation. If I asked you, said, what is the maximum slope? You would find f prime of 1, the slope at 1. We know that that's where the maximum slope happens. To find out what that value is, we would plug it into our slope equation. Okay, all right, that's all I have for you guys today. Tomorrow is Quest Day, so you're working on Quest during this period. I highly encourage you to go to a place that is populated with other students of mine. So it looks like some of you are sitting outside the gym or in the Great Hall or in the SAC or in the quiet room or kind of any of those places. Optimization is hard. There's only a few questions on there. Make sure you're working with other people. Do not procrastinate. This is not a Sunday night homework that you can save. I'll stay on if anybody has any questions. Otherwise, have a great day. Make sure you're working tomorrow. I'll see you next week.
Thank you.
Thank you.